Now we have already seen how to plot the IV characteristics for a given NMOS. Now we'll see how to do the parametric analysis. Just click on launch ADEL, click on DC operating point, component parameter. It will be the x-axis. I'll select the component will be VGS. From 0 to, let's say, 3.3. Linear, step size is 0.01. Apply. OK. Outputs to be plotted, select on design. I am selecting IT, drain current. Netlist and run. There will be an error. I think there are 2 errors. I'll tell you what the error is and then we'll directly approach to parametric analysis. Just add the model file. Now look here, I have not given a fixed value, I have given a variable value. How to give variable value? Click on the device, press Q. Just wait, I need to close ADEL. Okay, press Q on the keyboard. First it was a value 1.62. Now just give it a variable value VDS. I'll tell you why I have given VDS. Apply, press OK. Now launch ADEL. Repeat the steps that you have done for DC analysis, like plotting the VDS versus IT curve that I just now explained to you. Select VGS, press OK. Start is 0, end is 3.3 for example. Choose linear, step size let it be 0.01. Plotting 100 steps between 0 and 3.3. Apply, press OK. Again go to EDL. Now can you see this design variable? I have one design variable, that is VDS. Click on this dialog box of design variable and select copy from cell view. All the variables that I have given in my schematic will be copied here. Give a default value. Let's say I am giving 3.3. Now if I run, I think we need to add the model files again. Let me add the model file again. Outputs to be plotted, select on design. I am selecting ID, that is the drain current. Look, I have obtained VGS versus ID. Now, why I have given this as a variable VDS? Because in the previous video I explained you about the parameters. Now go to tool, go to parametric analysis, choose VDS as a parameter. For different value of VGS, we'll get the VGS versus ID. I repeat, for different value of VDS, we'll get VGS versus ID plot. Start from 1 volt. Go to a value that is less than this, the default value. For example, I'll go till 3. Keep total number of steps, for example, between 1 and 3 I want 4 steps. 4 steps mean it should vary 4 times. VDS should vary 4 times. Click on run selected sweep. Can you see? Can you observe? I have 4 values now. And you can see the VDS also. VDS 1, VDS 1.66, VDS 2.33 and VDS 3. Now we'll go and try to plot ID versus VDS. For ID versus VDS, what we have to do? Keep this as a constant value. Let's say 3.3. Apply. Okay. Now select ADL. Add the model libraries first. It's the most important step. Without this, no transistor will be instantiated. Go to choose analysis, click DC analysis, save DC operating point, component parameter. Now I have to vary this. I'll select VDS. Then I'll start it from 0, take it to 3 volts for example. Let the sweep be linear, step size 0.01. We all know what the graph is. Now we'll see how it appears on cadence. To be plotted, select on design, ID. Make sure you have selected the correct outputs from here. Outputs to be plotted, select on design. Then you can press the drain of the NMOS and this drain will be visible here. And it will plot the current versus voltage. Okay, we have obtained the graph. Now due to the technology, you can see this variation. This variation is due to the technology because the node is too small and it is going into diode type of region. It's behaving like a diode now. This we'll learn in our theory also. Now the same way we'll plot multiple graphs by varying the parameter VGS. Now name this as VGS. In parametric analysis, VGS, apply, OK. Again open, launch ADL, add model libraries. First, most important step. Right click on design variables, copy from cell view, you'll get this. Give a default value, for example 3.3. Again, DC analysis, choose analysis, DC analysis, save DC operating point, component parameter, select component. I am selecting VDS to vary. Start is 0, end is 3.3. Linear, step size is 0.01. 100 values will be plotted between 0 and 3.3. Apply, then OK. Again, outputs to be plotted, select on design, drain. I have selected the drain. Again, press netlist and run. You will get this curve, the ID versus VDS curve, that is the output characteristics for a NMOS. Now go to tools, go to parametric analysis. All the variables we have marked in our schematic will appear here. Select VGS. Range is 0 to, let's say, less than 3.3, that is 3. Why less than 3.3? Because the maximum value here is 3.3. Total number of steps is how many times I want to vary VGS. For example, this time I am varying VGS 5 times. So 5 plots will appear between 0 and VGS between 0 and 3. Netlist and run. Run DC sweep. You can see we have obtained for various VGS, VGS 0, VGS 0.75, 1.5, 2.25 and 3. This is how we can plot the variations for a given parameter for a given graph. For example, ID versus VGS or ID versus VGS or VDS.